Ronile Skein Dyehouse Lab Dip Training. When you begin a laboratory dyeing job, whether it's a set of customer approval dips, a trichromy evaluation, or a full set of spectro primaries, the very first responsibility is to make sure the dyes you're using in the lab truly represent the dyes used out in production. Nothing is more dangerous to shade consistency than using old, compromised or incorrect dye lots as your lab standard. So before anything else, go to the dye shelf and pull each bottle that will be needed. Check the label and make sure that the date or the lot number matches the current production. You'll also find that in our dye cabinet are piles of odd-shaped jars with handwritten labels, etc. Every single dye that is used and approved should be in a 1 litre glass squat container with an official-looking Excel printed label. I think we need to start putting either a lot number on there or we need to write the date that it was filled. Whatever, if you open up the jar, and the powder itself is not crisp and free-flowing, if you have to chip away at it or any signs of caking, or if you open the jar and you see blue areas and red areas, you've got to throw that away. Absolutely. Go and get a fresh jar of dye from the box of dye that is actually being used right now in the drug room. Once you've verified the dyes, the next step's preparing the 1 gram per litre dye stock solutions. These are the primaries used to pipette colour in either ahebas or beakers. The accuracy of these stocks determines the accuracy of every shade you will ever make, so it's important to prepare them carefully. Start by heating the distilled water to around 70 to 80 degrees C. That's almost boiling, get it hot, for a 1 litre stock. Start with about 200 mils of water. Add half a gram of water softener, EDTA, which acts as a softener to eliminate the hardness that destabilizes certain critical dyes, especially the yellow 199. Add 1 to 2 mils of buffer 5, which stabilizes the pH close to a 5 and helps prevent dye flocculation. Now add 5 drops of D90 wetter. This is to prevent the dye from aggregating. Now weigh exactly 1.000 of the dye, making sure the analytical balance shield doors are closed. Slowly sprinkle the dye into the stirring hot water. Mix for 2 to 3 minutes to dissolve completely. Once it's dissolved, top it up to about 900 mils and transfer the hot dye solution into a 1 litre volumetric flask. Allow it to cool completely to room temperature before filling to volume. Now this can be a fragile step so you don't spill any of the dye solution, which would ruin your accuracy. If you like, you can place a stirring rod at the top of the flask and touch it to the pouring lip of your dipper. By pouring the dye along the tube, it will avoid spilling any. Of course, if you do spill any, you must repeat the weighing, etc., and do it again. Hot solutions expand significantly, meaning that if you top them up too early, you'll end up with a dye concentration that's weaker than 1 gram per litre. Once the solution has cooled, fill the flask exactly to the 1 litre mark, tip it upside down and mix, and finally transfer it into a clean, labelled glass reagent bottle. Cap tightly, and this bottle is now your working dye stock. In addition to the dye stocks, you should prepare 10% or 100 gram per litre chemical solutions for all the common powdered auxiliaries. This includes the EDTA softener, levelling agents, wetters, antifoams, and Glauber's salt if used in the lab, and peroxide stabilizers. These solutions make measuring chemicals more accurate when adding small amounts. Just dissolve 100 grams of any given chemical in about 700 mils of warm water. Cool it fully and bring it to a litre. Label the bottle clearly. The general rule is that if you can accurately pipette volumes up to about 200 mils of liquid, but anything over that amount should be weighed directly as a powder. Sliders and acetic acid are not made into 10% solutions. Now that your solutions are prepared, it's time to set up the 12-beaker dyeing array. Start by placing 12 250 ml glass beakers on your workstation in neat numbered order. Each beaker must receive a Ronile label sticker, and each sticker must be filled out with the color name or number and the dip number. These stickers are critical because each one serves two purposes: beaker during setup, but secondly, once the beaker's contents are poured into the AHEBA dye tube, that same sticker must be removed from the beaker and placed onto the AHEBA tube in the correct position. This creates a direct one-to-one mapping between the beaker layout and the machine layout, preventing the classic errors where a tube is dyed with the wrong formulation. Before adding chemicals, fill each beaker with the proper amount of deionized water. For open beaker dyings, this is usually about 2 to 250 ml. For AHEBA dyings, the water will go directly into the tube, 800 mils. Now comes one of the most important parts of lab discipline: the sequential addition of chemicals. The rule will be simple. Add one chemical to all 12 beakers before moving on to the next chemical. Begin with a wetting agent or EDTA, depending on the recipe. Use the appropriate measuring device. Pipettes are used for 1 to 25 mils. 50 to 250 mils, you will use a cylinder. Anything above 200 mils, you will weigh as a powder. Add the measured amount of this chemical to each beaker that requires it. Then immediately tick the formula sheet to confirm that this chemical has been added. Only when you've added it to every relevant beaker should you move to the next chemical. This across-the-board approach prevents both omissions and double additions. After all the auxiliaries are added, follow the exact same sequential method for adding dyes. Start with the yellow. Pipette the correct amount of yellow solution into each beaker that needs it. Then tick the sheet. Move to red. Pipette across all beakers requiring red, and tick the sheet. Finally, add blue in the same all beakers at once manner, and tick. Please remember you've got to tick it off to prove that you've done it. Otherwise, you're going to end up confused and you'll end up doubling something and you'll wonder why the formulas are crap. Once the beakers are prepared, transfer their contents to the AHEBA dyeing tubes, moving each sticker from the beaker to the tube to maintain positional mapping. Now load your skeins. 40-gram skeins for the AHEBA, 800 liquor minimum, and 20-gram skeins for the Easy Dye, 300 ml liquor minimum. The skeins in the AHEBA must be tensioned on the stainless rods. They must be skeins that are wound from a single package. The rods are tensioned so that the yarn will rotate with the stir arm. If they're loose, the arm may move, but they may hang or float and remain stationary, leading to uneven dyeing. Start agitation before heating. Run the temperature profile appropriate for the fibre. For wool, usually 40 to 98 degrees C at 2 degrees a minute, with a 30-minute hold. For nylon, 3 degrees C a minute and a 25-minute hold. After dyeing, rinse warm and then cold. Finishing the skeins after dyeing is also a controlled process. First, use a handheld forced air dryer to dry the skein completely. This should take 1 or 2 minutes. Once dry, the skein should be lightly steamed for 5 to 10 seconds to restore the moisture. Finally, and this is an important technique, place the skein in a refrigerator for 2 to 5 minutes. This conditioning step ensures that the moisture level equalizes to a consistent level before you evaluate color. Wool is very sensitive to moisture, And refrigerating the skein provides a repeatable, standardized moisture content that ensures more accurate shade evaluation and reliable spectro reading. Do not process the standard in this way. It's already conditioned. Once everything is conditioned, make sure the sample is identified, moving the original sticker to the skein and stapling it on. The most efficient way to operate a busy lab dip operation is to prepare the next 12 samples during the dyeing cycle of the first set. Then as soon as the tubes are empty, you'll be ready to start the next round. Note that on the Easy Dye, one cup has a thermostat on its lid. This must be filled with fresh dyeing, or if not, fill it with cold water. If you leave it from a previous dyeing full of hot water, it will read this as the temperature of the whole set of cups and will not heat properly. It's safest to make sure one of the dyings is in that cup every time you start a new round. Once you get a dyeing that's considered a good match and ready to go to the customer, take the skein, the 20 grams, and make 2 poms out of it. 2 identical poms. Make sure they've got label showing customer, color, and the lab dip number and version. Remember, a lab dip will have a number, but then you've got a couple of different versions depending on what ads you've made, etc. So make sure that that label, remember, is what the customer's going to see. It needs to be professional and it needs to look clean. Make sure we've got an equivalent POM stored in our records so that we'll have something to match to when it's approved.